So for today, I'm going to do a quick reminder of yesterday. If I just gave you 5 numbers, you should be able to enter them on a list under Stat. 5, 6, 8, 10, and 14. Please enter those on a list in your calculator under Stat. And then you're going to do one variable stats, and you're going to compare with the kid next to you and see if you got the same thing. If your first number is different than theirs on the 1-var stats, then you didn't do it right. Remember, if you want to get rid of numbers, you hit DEL to get rid of old numbers, the DEL key. So, after we put those in, we had a whole bunch of things. I told you that you needed to know 7 of the 10 things on the list. If you haven't arrowed down yet, arrow down until you see Q3. And max, I guess one more time after that, max. That's the bottom of the list. Now I want you to recreate a box plot. We did this the other day. The lowest number goes here, aka the minimum. The max goes on the end of the whisker. This is called Q1. This is called Q3. And the line in the middle, that's the median. Okay, so identify all 5 numbers from our list and put them in. Anders, what was the low as in the min? 5. The max is 14. The Q1 is 5.5. Median's 8. That goes in the very middle. And the Q3 is 12. So now I'm going to actually do this the way you'd have to on a test. How would this be different on a test? You would have to number from 5 to 14. 6, 7, 8, 9, 10, 11, 12, 13, 14. You'd have to keep it to scale that way. You see what I'm doing? Okay, so I need the numbers between 5 and 14, obviously. And I need to count by the same thing. I can't count by like 1.2s or anything. So 6, 7, 8, 9, 10, 11, 12, 13, 14. Now it doesn't look right until I lift it up. So there we go. Now you put the box plot underneath that. Would you please all put the box plot exactly where it needs to be? Where 1 dot is underneath the 5, 1 dot is underneath the 14, and then make the box in the right place. You can't just like make a box and put the whiskers on. It has to be in the right place. So number from 5 to 14 and make your box plot right. Get started. Because again, you have to like label things, and you can't just like, maybe the box is going to have 1 whisker that's like really long and 1 whisker that's really short. You can't just like slap in a box and some whiskers. You know what all the numbers are. If you don't know what I'm talking about, talk to the kid next to you and try to figure out how to make the box correctly. Okay, if you're still not picking up what I'm laying down here, you remember how the Q1 was 5.5? Well, the way I drew it in the first place makes it look like this whisker is the same length as that whisker. It's not. It's not even close. So this Q3 is at 12. So this whisker goes from 12 to 14. This whisker only goes from 5 to 5.5. So that's the edge of the box at 5.5. See right there? That's the edge of the box. And then it goes all the way to 12. This is a super short whisker on this side. And this whisker is 2 units long. And then what about the median, which is the middle one, which is 8? You draw a line right underneath the 8. Now you can more easily tell that my data was like mostly on the left side. Most of my data like kind of is over here. Only that one number was way out to the right, so there was one number that was definitely bigger than most. Another way to say it is 50% of my data was in here. Oh, and this tiny little gap has still got 25% of the data. 25% here, 50% between these two. And the last 25% of our data is out here.
Is that always going to be like that?
Yep. Always. So, if I said, here's the scores on our last test. This is kind of how it usually actually looks. Kid got 100. Most of the class is between like 85 and 95. And there'll be one kid that's still got a 0 on it or something. Maybe not that bad. Maybe somebody got a 50. They just bombed the test. They tried all the problems. They got the minimum 50% grade. Do you see how most of the class is between, heck, 75% of the class is between 85 and 100? All right, so trying to make sure you understand how to read these box plots. And each of these chunks is 25%, 25%, 25%. And the last 25% is in this tiny little gap between 95 and 100. That means 25% of the kids got between 95 and 100. That would happen in here a lot. Probably even more than that. In fact, the median of that was probably more like 97 than 95. Okay, so that's a reminder on how to make box plots. A few of the important ones. This little symbol was super important. Find it in your list. Wake up your calculator if necessary. Did you have 3.2 for that?
Yeah.
Yes or no?
Yeah.
Okay, good. Then 3.2 is the what? Standard deviation. Very good. So, for instance, I told you that the standard deviation for IQ was 15 points. That means the typical person is 15 points away from the average IQ. In this room, I would say that it is not that way. I think in this room, because this is an honors class and we're in a pretty strong state for education and we're at one of the better high schools in that state. I looked at the list of the top 12 the other day and we were in the top 12, yay. And anyway, bottom line is we're in one of the best high schools and one of the best states for education. So I think the IQ in here is above average. So I think the average IQ in here is probably above 100. And then I think the standard deviation isn't that much. I think in this room, I think the average kid doesn't deviate that far from the standard deviation. So I would guess the standard deviation is less than 15. All right. So enough about standard deviation. It's like how much do you deviate from the average? So I'm going to just say one more time. In this room, I think the IQ average might be 105, which makes it above average. And I bet that the standard deviation is less than 15, so maybe it's 10. If this was correct, then the average person in here, technically not an average, but it's kind of like the average person is 10 away from 105, which means a lot of kids might be at like 115. And then there's a fair number of kids that could be at like a 95. All right, I think you're getting the idea. That's just reminding you what standard deviation is. Okay, on to this slide right here. This is the main thing for today, which I think was really easy, which is why I wanted to revisit the old stuff first, because this is going to be pretty easy. What's the difference between these two? They do look very similar. The difference is this is the numbers between 0 and 9. And this is how many students. And they're saying the grades that are between 0 and a 9. Okay, this is really weird because we almost never have anybody down that low. But it looks like there is about 8 people, maybe 9. If I zoom in right here, to me that looks like about 8. There was 8 kids that were between 0 and 9. Over here, this means there was about 2 kids, because that's 10. To me, maybe that's 3. There was 3 kids that were between 90 and 100. These are called bins. That's a bin. That's a bin. The people that got between 80 and 90 are in there. How many of them were there? There were 10. Do you get the difference? Over here, this is just one thing. People that have 4 siblings. Boom. It's not a range. It's just, well, actually, weirdly, this one is because it's 4 plus. This is not a range. It's just 3. You have 3 siblings. Actually, I'm curious. How many of you have 3 siblings? 2 people in the room. 3 people in the room. Okay. Who would be in the 4 plus category? 1, 2, 3, 4. Okay, good. And we could go on and on. But do you get, if there was 4 people in the 4 plus category, oh my gosh, I think we matched this perfectly. We do. This is like representing the people that have 4 kids or more. This is the people, not kids, sorry. People who have 3 siblings or more. Nope, this is or more. This one's just 3 siblings. All right, so the point is that these over here are groups. They're a set of a whole bunch of people, like a range from 0 to 9, and there were 8 people that were between 0 and 9. This is all weird because who has a grade that's a 0? I don't get that. That doesn't make any sense to me. So, all right, so this one, let's try to figure out if this one is a bin. Like, is there a bunch of things in here, or is there just one thing in there? Birthdays of students by month. Number of students. If you were to read this, you would say, well, there was 3 students that had birthdays in January. Do you get that covers how many days in January? 31. Anybody verify that? Is it 31? Okay. So there's 31 days that would qualify you. If you're on any one of those 31 days, you're in this bin right here. So I can tell this is called a histogram, as opposed to a bar chart where there'd only be one thing. This is a group of 30 different days in January that you could be in. Same with this, except it's 28 days in February, unless it's a leap year. See how this is a whole bunch of different days, and you'd be in this group? So this is called a histogram. It's a fine point, but you're going to be expected to know the difference on your next test. Histograms, it's like a bin of multiple things in that bar graph. All right, moving on. I'd like you to answer these questions with me. How many students were polled in each instance above? Well, over here on this bar graph, how many students were polled? Do I look at the number of siblings to see how many people were asked? No, I don't. That wouldn't make any sense. I look at the frequency and I go 5 and 10. That makes 15. Plus 8 more, 23, 26, 27, 28, 29, 30. They asked 30 kids. Do you get how I got that? I added up how many there were. This was the frequency over here for each thing. How about here? How long does it take you to get to school? How many people did they ask? That's what we're supposed to do. How many people were polled? bet it's probably the same group, so it's probably 30, but let's find out. 3 and 9, that's 12. Plus 5 and 5 is 10 more, that makes 22 total. This makes 23, 24, 25, 26, 27, 28, 29, 30. All right, Chase, put your phone in the phone jail. Oh, okay, good. Yay, and Tate, sorry, my bad. Here are the scores for the basketball team. Points earned in the game. Bar graph and stem and leaf? I haven't showed you a stem and leaf, but I'm about to. All right, let me show you. We already talked about bar graphs, those are pretty easy, but stem and leaf, let me show you what they look like. 0, 1, 2, 3. Everybody write this down, please. If you weren't with me before, get with me now. Copy that in the margin right now. All right, now we're going to go 1, 1, 3, 2, 2, 7, 9, 4, and 8. Let's imagine for a minute that this is representing the ages at a family gathering.
What is that?
I get you don't know what it is yet. Just hold on. If you've copied this, then you're in a good place. If you haven't copied it, copy it. I'll explain it in a sec. Just wait.
Where do you put that in your calculator?
You don't. You have to understand how this works, and you don't need to put it in the
I
calculator.
thought we were putting it.
Nope. All I asked was to copy this in the margin.
Okay.
Have you got it copied?
Yeah.
Okay, good. All right. So the question is, if this is ages at the gathering, try to process as I list them. There was a 1-year-old, another 1-year-old, there was a 3-year-old, there was a 12-year-old, there was another 12-year-old, there was a 17-year-old, there was a 19-year-old, there was a 24-year-old. Do you get where I'm getting these numbers from? And there was a 38-year-old at the family gathering. See how I got those?
Yeah.
Now that I've listed them from small to big, wouldn't it be super easy to figure out the mean, the median, the mode, all that stuff?
Yeah.
If you understand that that told me I had a 1-year-old, and then that told me I had a 24-year-old, I think you're getting the idea. Stem and leaves are super easy. They definitely are worth knowing though, because I've seen them on, like in the list of things you have to know for the ACT test. And this is definitely something that's on the state's tests. All right. So, do you have a question? Okay.
Good morning.
Okay. So that's a stem and leaf plot. If I just ask you some easy questions like what's the biggest, what's the smallest, that'd be pretty easy. But if I asked you for Q1 or Q3, you'd want to type them in the calculator? All right. Let's see if you really understood stem and leaves. Let's say this is ages at a different party. Who's the youngest person? 41. How many people were there? 7 is correct. Because there was a 41-year-old and a 77-year-old and a 78-year-old and everybody in between. Okay. Which was the person who was in the middle? There's 7 numbers. There is one in the middle. Take a second. 52 is correct because these 3 would be smaller, and then these 3 would all be older, 78-year-old being the oldest, and 52 would have been right in the middle. That make sense? I think that's enough on stem and leaves. Now let's go back here. Box and whisker, we did one of these earlier. Do you get the names of the parts? Q1, Q3, medians in the middle. Upper whisker, lower whisker, all of those make sense to you? All right. On to this one. if you had to make a 5-number summary, it's basically the 5 numbers that would be on the box plot. So if I were you and I was gonna just get the 5-number summary, I'd make a fake box plot. Like, you don't know how long the whiskers are and stuff, but I'd just put my 5 numbers there on each of the parts of the box plot. And then it says draw the box plot. You have to use a number line. This is a fake box plot because I didn't pay attention to how long the whiskers are and stuff. The real box plots, they're almost never going to look exactly like that. They're not symmetrical. And the line in the middle is definitely not in the middle. It goes on a number line. Okay. Interquartile range, let me give you some numbers. Let's say this was 8 here, and let's say this was 10. What is the interquartile range then? 2. Just take the bigger minus the smaller on the quartiles. These are the quartiles. All right. Bar graph. Okay, if I had to make a bar graph, is that the kind with the bins on the bottom of each thing? No, those are called a histogram. So how do you make a bar graph? Well, you number this in some logical way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is probably fine because the biggest number we have is a 9. And then how do you number this then? Same idea. You just number it 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's take a second to actually make a bar graph for this data. There, I numbered it. Do I have to put them in order from small to big? All right. So the way I do it is I cross them off as I went. There's 3 2s. Ooh, there's a 4th 2. There's a 3. There's a 3. 2 3s. Cross them off as I do. And there's a 4. There's only one 4. And there's 3 5s. Three 6s. Wait a minute, there was 4 5s. Just realized there's 4 5s. Gotta squeeze in another 5. And then an 8 and then a 9. Now the cool part about listening like this is you start realizing, oh, so you're saying there are 4 2s. This is where the freak goes. F-R-E-Q, as in the frequency, as in how many you had. 4 2s, so right above the 2, I make my bar. There were 4 2s. About the 3s. There were 2 3s. It's half as tall. I think you get the idea. The thing that's probably the most important is that the frequency, like how many there are, goes on the y-axis. From here, I suppose I can just finish it. I have one of these 4s, 4 5s, same height as that other bar. And now the 6s, there's 3 of those. And then 1 8 and 1 9. Quick, but I'm done. That was a bar graph. Now, if I was going to make this into a histogram, I would have clumped things together, and I would have said like 2s and 3s, I want all of you in one bar. 4s and 5s, I want all of you in one bar. 6s and 8s, I want all of you in one bar. And then that's kind of weird because I'm leaving the 9 alone. So this probably wouldn't be a great one to use a histogram on, because little sets of 2 aren't like working out real well. Maybe I should have gone 2s and 3s, 4s and 5s, 6s and 7s, even though there aren't any 7s, and 8s and 9s. That would have been a way to do the histogram. Okay, so there's a quick overall big picture. Like, do you remember what this is called? A box end whisker. It's got the five number summary. Those are 5 important numbers: the min, the max, median, sorry, in the middle, and Q1 and Q3. Is this a bar graph or a histogram? Look for bins. Is this a bin? Like, does it have multiple things in that little group there? Nope. This is just people that read 2 books. It's not people who read 2 or 3 or 4 books. Okay, so that's just a bar graph. And now you have a worksheet and you have time to work on it and you have time to ask me questions. I looked at this one ahead of time and I determined that problem 2 looked like it might not work. So I would say skip number 2. The rest of them are doable. You've got lots of time in class. Please ask questions if you're stuck. And I want a quick, big picture here. This is our last unit on stats. We're going to be using the calculators for it, so the test will have a calculator involved, but the test isn't coming till the final.
Oh, so we don't have a test on this?
You have a test on this, it's just built into the final. There are several questions on your final about this. But the good news is, that means that we don't have any more regular tests or tutors.
So we just have one more test.
All you have is one more test, and it is the final.
So this is our last content?
This is your last content, well, not today, but we have several more days of stats. I gotta teach you a lot more complicated stuff than this. Today was super easy. I hope you feel like it was like a day from middle school or something, because we've had histograms before. You know you've seen this stuff before. But bottom line, I'm just trying to tell you, you're in your last unit on stats, and it's only tested on the final. So, please ask questions about it though, because it counts on the final. And you can't retake the final? So you get one shot at that. And that's all I got for you for today.